Okay, so I'm going to try conventional thermal printing with a modified Gen 4 Pyrojet printhead that has been designed to essentially be a Gen 2 printhead with a Gen 4 JLPCB circuit boards. So here goes nothing. Well, it does seem to work, if only poorly. So, there you go. Thermal print by hand using the Open Pyrojet Gen 4 printhead modified to be like a Gen 2. Not very good, but it's something. It's a start. Okay, we're going up to 3 volts, 500 milliamps. Maybe we'll have to go up a little bit higher. We'll have to go to 3.3 volts. I don't know if you can see in there. There doesn't appear to be anything happening. Maybe there's some heat getting down there. Oh, there it is. Yeah, there is something getting down there. Turn it down a little bit. Try again. I'm gonna start over. went up to 3.5 volts continuous at 500 and, oh, it's 600 milliamps. Maybe we'll go down a little more than that actually. 400 milliamps. We're currently working at 1.4 watts. Maybe we need a little more than that. 2 watts. There's currently no visible... Oh, there it is. Yeah, there you go. Yep, we're currently working at 2.1 watts, continuous, no pulse mode operation at all, and it seems to be working just fine. The filament gap to the head is, or to the paper, is probably on the order of a millimeter, so honestly kind of surprised this is working at all. Getting pretty warm. Okay. Put that down. We'll clear this off. There you go. A little longer this time, and the heater hasn't burned out, so it should still be reusable. So yeah, it's obviously sort of repeatable, but yeah, if you're looking to build a thermal printhead or something like that, the Gen 2 design might be somewhere to look. It's pretty easy to make. The designs and schematics are all online, and I can put up a modified version that works with the Gen 4.4 like JLPCB style of printhead a little later if there's any interest in it. I think this might also be useful as like almost a digital screen printer. Perhaps we could have the same sort of thermal printing process work by having like thick film paste, like silver ink or something like that, squeegeed onto a surface by the printhead, and at the same time sintered or melted onto the surface, or somehow reacted with the heat from the heating elements onto the surface to make circuit boards. Almost like screenless, on-demand screen printing, where the squeegee is and the screen is digitally reconfigurable to print custom circuit patterns. So yeah, it's kind of an idea I had. I haven't really been able to execute on it too well, but I just wanted to see if a really relatively simple Gen 2 remake could perform to some level on thermal paper as just a starting examination. I think the activation temperature for this particular brand of thermal paper from Office Depot is 160 degrees Celsius. So yeah, clearly it's a little rough-hewn and a little crude, but it's a work in progress, and this seems like a good start. And 160°C is enough to sinter some very low melting point nano-silver inks or nano-silver solders. So that might be a direction we can look in the future for some low-hanging fruit as an easy win, I suppose. Something that might be fairly useful to a few of us anyways, but is really just a beginning, and just a good opportunity to work on closed-loop control and things like that. Yeah, a relatively simplified approach, I think, because of the simpler physics involved and the much simpler design involved in making such a thing work. It'd probably work even better if we could get higher printhead dissipated powers by just running the printhead in pulsed mode as we did normally. So yeah, something to think about. This came across my mind this morning, and I just wanted to try and demonstrate it to myself to make sure I wasn't crazy, and show it to a few of you who might be interested in building completely open source thermal printheads or similar such technologies. Since there aren't really any good projects out there for thermal printheads that are open source in terms of their driver, electronics, the actual printheads themselves, the elements that is, and of course all the adjoining software and such. You can buy a few kits online from like Adafruit, but they're mostly made with closed source like Chinese driver boards and controllers, and the printheads themselves are typically made in some factory elsewhere where the process, you don't really know what the process is, and you don't really know what the limitations of the heating elements are, except for what they tell you. With Pyrojet, we can go to much higher temperatures and much higher powers, and we know exactly what all the components are, so modifications are much easier. So yeah, if you stuck with me through all of this, thanks a lot for watching, and yeah, I'll see you next time I decide to make a video for Pyrojet, or the next time some strange project idea crosses my mind. And I'll probably do a few people have asked actually for a shop tour, so I'll probably do one of those pretty soon. I've been Michael with the Open Pyrojet project, and thanks a lot for your time.